Okay, so I'm going to prove L'Hopital's rule for the infinity case. So I need to prove that f over g minus L is less than epsilon. So that's where I'm working towards, and I have a good start. I have L minus epsilon over 2, L plus epsilon over 2, and I almost have f over g, but then I have the subtraction thing. So I'm going to get around that, but I'm going to multiply all three of these by, well, I'm going to change my color to black here. I'm going to multiply this times g of x minus g of t over g of x. And that's going to cancel with these, and I'm going to be left with just a g of x in the denominator, which is what I want. Now, the problem is I have to do it to all three of these. I need to, whatever I do to one side of an inequality, I have to do to the other. So I'm going to multiply this by, notice if you simplify this, it's 1 minus g of t, where remember t is a constant, over g of x. And this same thing, times 1 minus g of t over g of x. That's what I'm going to do, but I need to be a little careful about doing this, because I need to make sure that this thing is positive. I need to multiply by positive, or otherwise my inequalities are going to flip. This is where the second delta comes in. The second delta comes in by, basically, I'm just going to make sure, right, the fact that the limit goes to infinity means that for any m, any constant I pick, I can always get an x that's, a g of x that's bigger than it. So I'm going to pick my m. I take m equal to g of t. Remember, t is a constant. It's just a plus delta 1. So if I pick m equal to g of t, make that so it's readable, g of t, since the limit is infinity, that says that there has to be some delta such that as long as I'm within a plus delta 2 of it, I'm going to be higher than g of t. That guarantees that 1 minus g of t over g of x is going to be positive because g of x is bigger than g of t, so this thing is less than 1, so I get 1 minus something less than 1. That ensures that everything's positive. So that's where my delta 2 comes in. So this all becomes, well, I'm going to distribute this through. L minus epsilon over 2 times 1 gives me L minus epsilon over 2 minus L minus epsilon over 2 times g of t over g of x. That's just the left side. The middle becomes f of x minus f of t over g of x, which is good because I want to get just f and g there. And this is less than or equal to, this is going to be ugly, L plus epsilon over 2. I want to write this as plus. I want to write it as a plus. So what that means is I'm going to get plus negative L plus epsilon over 2 times this g quotient. Plus negative L plus epsilon over 2 times g of t over g of x. That's big and ugly. Okay, I'm getting to the point where things are going to be good soon. Now, here my basic idea. Let me just simplify this. Right, I'm going to simplify this, and then that'll probably be where the podcast ends. But before I do, I'm going to split this up into f of x over g of x, which is good, which is what I want in the middle, because I'm going to make this between L plus epsilon and L minus epsilon, minus f of t, remember t is the constant, over g of x. And then I'm going to move this to either side. Okay, so when I do that, what I get is I get L minus epsilon over 2 minus, there's a little bit of algebra here, but trust me, this is going to work out just fine, L minus epsilon over 2 times g of t plus f of, or minus f of t, because I'm adding f of t both sides, and so I do minus, that's a plus. That's going to give me all over g of x. And I'm going to continue with this algebra in the next screencast. Please wait.